Hi, hello, Professor Rashidi. I'm Deson Maylor. Here's my project for design and manufacturing. So, my first topic is metal casting. It's a manufacturing process. I have two manufacturing process and like three design processes. So, metal casting is one of the oldest forms of manufacturing, right? It's thousands of years old. Um, It really started with like the Bronze Age. They casted bronze things, and it consists of pouring molten metal into a mold where the metal will cool and then take the shape of like the cavity inside the mold, right? So there's a lot of things to consider. You consider solidification, like how the metal will shrink and this shape as it cools, right? Because when you heat up the metal and it turns into liquid, it's going to expand, but when it cools back down, it's going to be a smaller size, smaller volume. You need to consider the flow of how the liquid metal behaves, right? When you're pouring that liquid into that mold, you don't want any air bubbles or gaps or anything that can mess up the final workpiece. Next, you consider the heat transfer, right? You're working at high temperatures, and the rate of heat transfer is going to affect how the material cools, right? You want it to cool a certain way so there's no cracks or anything, and like the mold doesn't crack either. And then finally, the mold material. The mold material affects the heat transfer and solidification, but it also affects the final surface finish, right? Um, like a smoother mold and mold material will make a more fine, more polished surface. Um, so casting is really great because you can make very complex geometries, right? You can make things with cavities inside them, very fluid, organic looking shapes. However, the precision isn't exactly perfect, right? A lot of the times, once something is removed from the mold that's that was used to cast, you need another process to more refine it better. And but casting is a great first step in the manufacturing process for a lot of things. A lot of things are still casted today. So after you might cast something, one of the things you might do to refine it better is machining it, right? And machining is just a process in which a tool removes material from the workpiece and then kind of shapes it that way, right? So it's subtractive, unlike casting, where hopefully all the metal that you melt will be used for the final product, right? You don't melt more metal than you need. For machining, you usually start with the material or workpiece that's larger than your final thing. Well, not usually, always. It has to be larger because you're removing material. So there's a lot of types of machining. There's turning, milling, drilling, grinding, but all these things essentially work the same. There's a high speed tool that chips away at the material that's rotating, and the chips fly off. That's the pieces of the material that are being removed, and then the final workpiece that's left is like ideally what you want, right? So it's using a lot of things, as you can see, and there's a lot of advantages, right? Unlike casting, machining is much more precise, especially nowadays. It's much more repeatable, and the materials is a lot. There's a range of materials they could use more, right? Casting, some materials aren't the best for casting, especially casting complex shapes, right? But more materials can be machined, especially if you take the time to consider the type of tool you need, the speed that you're machining it, and those things, right? There are also a lot of challenges though. Machining wastes a lot of material potentially, right? Since those materials are being chipped away, a lot those aren't usable anymore, right? Also, The tooling cost, the overhead for the initial tools are can be hundreds of thousands of dollars, and it's very time intensive, right? It could take hours, maybe even days to like machine a part, especially to the level of precision that you might need. Especially if you're starting from a very big work piece, right? Not only is that since it's such a big work piece, you're creating more waste, and it's going to take more time. So next we have product maturity, right? Once you start, once you come up with the idea to create a new product, it starts kind of here on the S curve, right? And the S curve shows the flow of product maturity. So when you start a product, initially the first thing you want to do is you want to make the product work, and then slowly you refine it, you increase performance, increase efficiency, reliability, minimize costs, right? And but this takes time, right? This is over time. You're not gonna start off with a mature product, but once you do eventually have a mature product, then you kind of have decisions to make, right? Because the product isn't changing anymore, it's getting stale, so you need to innovate, right? And if you don't innovate, you might get outcompeted in um, the industry that the product is performing in. So just here's some more about product maturity. Um, there's high competition right towards the end, maybe not towards the beginning, but towards the end as it becomes more mature, there's gonna be a wide influx of other competition, right? There's slower growth towards the end, and the price is gonna be reduced. A lot of things now are very mature. Smartphones are very mature now because initially there weren't that many smartphones. Apple was kind of the first to do it. They innovated, and now they're on iPhone 16, and they all do the same thing, right? An iPhone does the same thing as an Android, as a I don't know, Google phone. They all do the same thing. So they keep trying to innovate. Here's the product lifecycle management slide. As you can see, product lifecycle management includes like managing all these different aspects of design, and we're gonna go a little bit more into depths in the next slide. So you have systems engineering. So systems engineering, you support the technical development and product functions. Design automation, this is computer aided design, this is some CAD. You kind of just want things to go smoother, more with machine work, kind of like AI is killing our jobs. The bill of materials, you need to know what parts are being used for manufacturing. And manufacturing engineering, whether you're designing for manufacturing, for assembly, for whatever you're designing for, all these processes need to be incorporated if you're managing the whole product life cycle. Product life cycle is from cradle to grave, right? So you're thinking about how you're building the product, how the product is being used, and what you're doing at the end. If you're recycling, disposing of it, right? Cradle to grave, that's what that means. So here you also have service diagnosis and warranty. This is kind of like the middle and towards the end of it, where if something goes wrong, you're servicing the product, and there's like a warranty in case something happens to it. And then product portfolio as well. And here's some more things about product life cycle. And finally, you have design for cost. So when you're designing for cost, there's a lot of cost that goes into effect when designing something, right? There's material, purchase parts, labor, tooling, overhead, and all these can be broken down like this, but they all add up to the total list price for the material, right? The total list price includes the profit from the material, including and not just the cost it takes to make it, right? This is the entire product cost breakdown. So there's some like definitions for what these things mean. So direct costs, these are all things that directly go into creating the product. You have material costs, the purchase parts, the labor, the tooling. Then you have in manufacturing costs. There's also variable costs and fixed costs. Variable costs can be affected because sometimes as you produce something, low volumes of it can be more expensive per part than a bunch load, right? If you make one car, it's probably going to be expensive, but if you make 10,000 cars, the price per car is going to be variable, right? That's not the same as like the price per material because the material needed for each car is going to be the same. But for like tooling and all that and like those things, that what causes the price to be variable depending on how much you make. And here's just some more information for design on cost. And that's my project. I feel like all these things are kind of important. There's a lot of other things. This is nowhere near the scope of everything for design and manufacturing, but this is a good start for any engineer.